My name's Stephanie Kim. I work at Algorithmia. We're a small startup in Seattle, actually right down at the market, which is pretty cool. I'm a developer evangelist and software engineer there, but I kind of more play data scientist a little bit too. I'm the founder of the Seattle PyData location and former organizer. I handed off the baton to a couple of wonderful ladies, Wendy and Erin. If you're ever in Seattle, definitely check us out. We've got a really good group of ladies, and we open it up to anyone who actually wants to come, regardless of gender. So it's just a little spiel about me. That's actually a picture of me at PyData last year in Seattle. And so that was fun. I spoke on a similar topic, some NLP stuff. I do some machine learning at work. I do lightweight data analysis. I also do some technical writing. I write the documentation. So if you're ever on Algorithmia and you're like, this documentation sucks, definitely hit me up, and I'm in charge of it, so I'll fix it. About Algorithmia, so we make state-of-the-art algorithms, and it's an open marketplace, so that means they're accessible to anyone, and you can also contribute too. So it's, I guess, kind of like an algorithm GitHub. So the cool thing I feel about Algorithmia is you can host your data models and turn them into an API endpoint just with seriously a few lines of code. It makes it super easy. I'm no API designer, and it makes it really easy to, say, put your NLTK, your scikit-learn, even a deep learning algorithm up on the marketplace, turn it into an API endpoint, and then you can consume that. You can have other people consume it, and you can charge for it or make it free for people. So that's kind of cool. You can actually get royalties from your work. So this talk, I guess we can move on to the talk. And as I say, I kind of glanced over some of that stuff, but you can read my notes for more details. So this talk is about triaging feedback form or customer service data. So it's unstructured text data. Triaging, you've heard of it, and in hospitals where nurses, there's a triage nurse, and she'll decide, what patient gets what care in what priority. That's kind of how I felt the approach we needed to take with our feedback form data. We use Intercom, which is a customer service platform, and we respond to messages and read messages on a daily basis, but we don't really get the big picture. So I wanted to kind of see how we could get a bigger picture and check out trends so we could be better prepared to point the users in the right direction, whether it's better documentation in a certain area or just maybe we were completely missing something on the UI side and people couldn't find what they were looking for. So that was the point of this analysis. So why would you want to know what your users are thinking? Because we tend to think we know what our users are thinking, but in reality, we don't even know who our users are half the time. So these are some things that I have found in previous projects doing analysis on feedback. So I was this time around, I kind of knew what I could find. So it was interesting to see some patterns that came up that were also in other projects that I had done. So as I said, we read every message that comes in through Intercom every day. And our customer service, that's a big part of who we are. We really want to reach out to people and find out what their needs are. But, it's kind of hard. Your memory plays tricks on you, and you're like, oh, everybody's talking about this one thing. And maybe it's because you had an invested interest in that one thing, and you were personally involved in the project. Or maybe it was just a big demo that blew up. And it felt like, oh, yeah, this is huge. Everybody's talking about this. Well, maybe they're only talking about it for 2 weeks. And so I wanted to look at the more long-term trends. And what I mean by long-term trends, we're only about 2 years old, so not too long. But still, it's important to try to gain some insights. So what is Intercom? Again, I said it's a customer communication platform. And those are kind of their three main segments that they try to kind of sell you on. They do live chat, customer support, and marketing automation. We mainly use it for user messaging back and forth, and we also email our users this way. When we come up with a cool use case for an algorithm, we come up with a new algorithm that we are hosting on our platform, and then new tutorials that come up that we think that people might be interested in. So here's like a brief synopsis on the methodology. So I know it's called PyData, but a lot of this talk was in R. PyData is always open to doing data analysis and data science in other languages. So I didn't feel too bad. I did a lot of the data wrangling in Python and used some algorithms on Algorithmia. My kind of focus was, since I didn't really know, or I didn't want to assume anything about my data, I was like, okay, I'll use some unsupervised clustering algorithms to try to get some patterns. And then I did some LDA, so topic modeling, and then I also did some logistic regression and some time series sentiment analysis. What's funny is like you think you're like, okay, I've got a decent amount of data. I think I had like more like 1,000. I wrote 700. I think it was more like 1,000 comments. And then after using Python, and regex to clean it all up and extract only what I needed and remove duplicates, there were only like 500, less than 500. So that was a little bit disappointing. But I don't know if you guys have heard of Intercom or use it, but the data you get back from your user messages is really dirty. It's the most excruciatingly painful data that I've ever worked with. But I got through it, so I moved on to R to do the analysis, visualization, and interpretation. Those are the different algorithms I used on Algorithmia. Python, as I said, was just general data cleanup. And so, I used the lemmatizer, the part of speech tagger. So because I only wanted nouns, because I was generally interested in the topics. Of course, I used everything else for sentiment. But I actually used LDA, one of our LDA algorithms for kind of an exploratory process, because it is like 3 lines of code, pretty much, to get the results. I was like, okay, well, I want to know if this is even going to be useful. I knew that I didn't have a ton of data, so I didn't actually know if I'd come up with any useful topics. And the reason I moved to R after I realized, okay, this actually could be helpful, was because of the posterior probabilities, which I used to predict new topics off of my test set of data. So it's kind of using the best tool for the job sort of attitude. And these are the different algorithms and analysis that I ran on R. So Barbie she had a rough time before I cleaned her up. Actually, I didn't clean her up. Someone else had to go through this process. But yeah, so that's my data before and that's my data after. As I said, Intercom data was it was painful. It was, I used JQ, which is a JSON parser for Bash, to get my data through Intercom, filtering out a little bit. Definitely had its own pain points, as I wrote. And then I filtered out, some of all of our admin messages, and then there's some fun stuff that's some of the responses were in the body of the user message, had to filter that out with some regex. It was probably the worst, dirtiest regex I've ever written, but it happened. So I think I already kind of covered that, what I used as far as only nouns were used. I mentioned I removed duplicate messages, but I also removed sentences shorter than 4 words and words shorter than 3 characters. So to get the data in R-friendly mode for natural language processing, which, disclaimer, this is the first time I've used R for natural language processing. I've used it for other things, but you have to turn it into a document term matrix, and it's the same thing, I think I'm not going to remember the right name in Python, but there's a similar function that does it in Python. So it mathematically describes the frequency of terms occurring in documents. I used TF-IDF and I removed sparse. There's a remove sparsity or reduction sparsity. I can't remember the function, the R function, but it'll help take out any documents that only have a few terms that you're not going to be interested in. So here's my first lovely plot. This is kind of the more exploratory, part of the process. Well, the whole project is exploratory analysis, but R makes it super, super easy to do any plotting. So I've used Matplotlib. I haven't used Seaborn, but I've heard it's pretty good. R just honestly, using RStudio, it makes it so fast and easy to, get your plots up and running. It's a little bit more painful to get the data the way the library needs it to be. But so these are the 15 most frequent terms. You can kind of see that air and image are really sticking out there. And we had a demo, a colorization demo that reached a lot of people. And it was great because, there are all these people super interested. Unfortunately, we're looking for an app that did this for you. They weren't developers. We're a developer platform, so it was reaching some people that were having trouble even just using the demo. So that's kind of why we had a lot of image and colorization topics when it was just a brief snippet in our time. I did remove words like work, algorithm, photo. Those were more than double what the next most frequent word was. So it was just creating a lot of noise. Obviously, our product, our algorithm, so it just wasn't pertinent.
Did people actually write the word datum?
No, actually, thank you. I did mention, that'd be really funny if they did. No, it's the canonical form of data. Yeah, so you'll see like, I can't remember what API is. It's kind of funny too. So yeah, I didn't switch them back because that would just be a painful process. But no, that's, good catch on that one. So yeah, the lematizer does that. Against my better judgment, I added a word cloud because some people like them, probably the same people that like pie charts. Probably no one in this room likes either. But I did it because it's super easy in R. Again, it's like super painless, a few lines of code to get a word cloud going, and business ops people like them. So here's a clustered dendrogram, and I kind of went through these slides at work, and nobody, I think maybe one person had ever heard of them. I was like, oh, okay. So I think they're really useful. Some people don't have a hard time, kind of interpreting them, but I find them very useful because, and they're used in biology a lot because of the hierarchical structure. But I definitely find them useful because you can kind of see like the relationships between the different clusters and how they relate to each other. So, and if you don't know anything about dendrograms, so the branches represent relationships between the groups of terms, and the branches are called clades, and then the leaves are the actual labels. So you can see from like left to right how they relate to each other, and also height if they're closer together. So see the email, product, website, search, video, see how they're all kind of tightly nested together in height. That means they're more closely related, and they're more closely related to company and service than they are, say, air, which is again, moving left to right. So it's kind of cool because instead of just seeing like topics, like a topic modeler would give you, or k-means cluster algorithm would give you, you can really see how they relate to each other. See at the end, you can see the image, color, colorizer, picture. It's very clearly the demo that we did on the colorization demo. There's some interesting in the middle, like more user count groups, and I thought that was kind of interesting. And so what I do like with these kind of exploratory unsupervised algorithms, I do this and then I'm like, okay, well that's great, but what does that really tell me? It doesn't tell me really much at all, except that there's these interesting groups that come up. So then I do some basic information retrieval with unigrams or bigrams and pull up the actual documents that these some of these word groups fell into. Oh, right. So I originally looked up how to do this in Python, and it looked extremely painful. Then I found like, is it painful? Okay. So I did find some code that looks like it would work, that looks like it's less painful to do, but I didn't run it, so I don't know. This is how you would make a dendrogram in R. Pretty simple, pretty straightforward. I added like the very basic things that you need to do to get it in the right, data format. I actually did not use this, like 20% might be pretty common for a large corpus. Mine was fairly small. Mine was already fairly sparse. So I didn't actually use that low. In Python, again, I did not run this code, but I took it from this site here and this tutorial. And they had been doing a lot of different things in between doing dendrograms. So this is kind of what I grokked through and decided, okay, this looks like it would create a dendrogram. Oh, the count vectorizer is the same as the document term matrix in R. So it looks actually pretty similar, but I just don't quite trust that this works because everything else I read was just like this huge, script to get dendrograms to work. So my coworker, after I was talking about this, we actually are bringing R to our platform. We already have Java, Scala, Ruby, Rust, Python. I think that's probably it. And then we're bringing R. It's in beta mode right now. If you want to be an R beta tester, just let me know. And he had to learn R kind of on the fly to build the R client to get it supported on our platform. So he was like, oh, I could create an algorithm to, let you build an R dendrogram on our platform. And this is all the only code that you would need to run it. Pretty much, it's in he's not a data scientist or data analyst, so he didn't really know like the customizable features that it would need. So I'm kind of helping him make it a little bit more robust. So another unsupervised algorithm is k-means. And so with the elbow method and trial and error, I found that 3 clusters worked pretty well. If you go to 5, it breaks down image and error into 2 separate clusters, and then the rest, 1 cluster. Error and image did seem to kind of be somewhat tied together. I thought this one was fairly interesting because it had a kind of a hodgepodge, but video and search fairly close together. And so product, website, email. So I thought that was kind of interesting. I'm trying to keep my eye on video stuff because we're just kind of starting to play around with more video algorithms. So anytime that has popped up, I'm like, I should look that up and see what people are saying about videos. And then the other one's kind of a mess of all things developer, credit, code, call. Those are really generic terms that we're going to see that don't really give us a whole lot of information. So I've never had the greatest luck with k-means really bringing me any useful information. I keep using it and being hopeful. And maybe it's just the unstructured text data. Maybe it's, my corpus are too small, but I keep going and I keep trying. I have done scikit-learn or k-means and scikit-learn, and honestly, R and scikit-learn are neck to neck on like the ease of use. But again, R and R Studio come in ahead on the ease of visualization. I remember when I used it in scikit-learn, you really have to, you have to write a little bit more code to get your labels to print out your labels and to actually match them up on the plot with the data points. So in this one, R is a little bit easier because a lot of times, you definitely want to visualize your k-means. Oh, and R, actually, I should point out, there's also ways to plot it in 3D. So that's kind of cool. That's just adding a cluster. And so remember I said most everything was done with just nouns because I was looking for topics. I added verbs in, and it created some clearer clusters actually for this one. So it's always good to play around like with your corpus and say, okay, well, I'm really interested in topics, but sometimes that's just not enough information for the algorithm. So I thought this was a little bit more helpful. Call, company, service, make. It looks like there's maybe some business outreach that is happening, and maybe intercom's not the best way to go to let those people communicate with us. So possibility for like an actionable insight is that we can create like a special email for them for business outreach because we do get a lot of those through intercom, and they do send us duplicate messages pretty often. So
could you speak a little bit as to the clusters?
Here, sorry, I'll go
what you're
back.
seeing. I'm having a hard time reading what's actually inside the clusters. So
Oh yeah, sorry. It's probably it's really tiny.
What you see grouped there.
So with this one, I know that print. Actually, I apologize. I should have made that font quite bigger. So the bottom one, cluster 3, it's red. It has call, company, service, make, and that's the one that I was talking about is more kind of business-oriented, business outreach that we get on intercom. The upper left one, number 4, image, air, colorize, which I did mention that, colorization demo. We're getting people from genealogy. Someone mentioned it in the genealogy newsletter, so we were getting a lot of 80-year-olds who are adorable that saying that they wanted to colorize their black and white photos. It was actually pretty awesome. But that's, they can do it as much as they want on our demo, but we don't build apps. So we couldn't quite help them there. And then number 2, which is the pinkish one, that one is data, site, user, picture, question, support, send, account, so basic user account stuff. I don't find that one entirely helpful. There might be some issues. It does make me wonder and want to investigate whether people are having problems understanding their account, how to interpret, like the account, the profile page. So that's definitely something to look at. So again, it just gives you kind of a focus in maybe pulling up, those documents that those terms occur in. And then the one big green one over there, there's product, email, website, information, credit, learn, read, add, page. That one kind of looks more along the lines of the documentation and tutorials. And it doesn't give me a ton of good insight about what possibly could be going on. So that one's not as helpful. But does that answer your question? Yeah, I totally apologize. It's teeny tiny. So hopefully this is clear. It's a nice table. So LDA results. I said I tried LDA on Algorithmia. Have a couple LDA algorithms. Had actually really good results there, but didn't have the posterior probabilities to predict any new topics from unseen data. So I used R's implementation, and I do feel like that happens with everything I've done. R just I mean, it is a statistical tool, but it does take everything a step further. And I would love to see, scikit-learn and pandas and other Python libraries do the same thing and take, what they're doing is great, but just take it a step further and give you maybe some more metadata. So I just kind of, in my notes, I just kind of gave some paraphrasing and quotes about LDA because it's kind of I'm not a statistician, and when I look at the LDA, explanations, and I'm pretty good about reading academic articles, but the LDA ones they can be a little bit painful. But so it's just it's a topic modeler. It's a way to, find sets of topics that occur in documents. And I used Gibbs sampling. So that's just a way to sample from slices of data. So it's a way to get a better random sample. And then again, I was just looking for topics, general topics, to where I could dig a little deeper. I was finding trends between the dendrogram, the k-means, and the LDA results. Obviously, topic 4 kind of, beat that one into the ground. But topic 3 is a little bit the same as topic 4. It's, again, the colorizer, some of the confusion around how to use it, because the target user wasn't exactly who we expected it to be that was playing around with it. So number 2 topic, input, credit, product, company, error, the results weren't super great. And that's probably just because of my lack of data and the lack of time span. But credit was kind of interesting to me because we are, our platform is based on a credit system. 4 minutes? Oh, dang, I need to hustle up. Okay, so anyway, here's my LDA results. The first one's the most interesting to me because video and search keep kind of popping up together. So I really want to look at what people are talking about with video. Again, I used R for the posterior probabilities. I ran so you don't have to run your all your data through the LDA model again. You can predict the topics off of unseen data. So I did that, and I came up with, these are just the top 7, but documents, and it labeled them as one topic, the first topic that the LDA model came up with. Oh, I do want to show you something cool, and it's kind of nice that I do have this set up. So this is something that, again, differentiates R, and in using pandas and scikit-learn and everything, it gives you this library. LDA Viz is super great at visualizing LDA data. You can look at the different topics, the most relevant terms, change the lambda metric, and kind of see let's see if I can find a word. Yeah, okay, so site, the term site appears in those 2 topics. So it's a really cool way to visualize that. But since we're kind of in a hurry. Sentiment algorithms, I didn't have enough data and I didn't have time. I can't see that, sorry.
1 minute.
Oh, 1 minute. Okay, she's keeping me mute. Thanks. Okay, so sentiment, I didn't have enough data or time to label, so I used one of our algorithms. And we have a lot of sentiment algorithms on Algorithmia. I used forecast in Zoo and R. I've used time series in Python. They're both pretty great and pretty easy to use. I don't really have any thing to say about one versus the other. R has forecasting functions, so you're able to forecast all the. This is using a smoothing function. a basic exponential smoothing function. This is for negative sentiment after smoothing. The Holt-Winters filtering, it also is a smoothing function, and Holt-Winters, that blue line is the predicted forecast for that time period, not ahead of time, but for that time period. And then there's another function for Holt-Winters that allows you to predict in the future. It is about, I think, 4.2 positive frequency for the next 5 months. You can alter it if you want it like the next 2 years or the next month, and so that's pretty nice. It's very customizable. And negative was around 2.8 counts. We're done. Sorry. So I didn't get to logistic regression or the wrap up, but I will put I'll put the slide deck up and share it, and I won't take out my notes or anything, so you can read everything that I was thinking while building this. Also, there's resources available, and before you leave, there's a code to try algorithmia, and you get 5,000 free credits every month, and then here's 100,000 extra credits with this code. So, great, thanks guys.